All right. If you guys please would turn to page 149 in your textbook. Okay, we're on page 149. All right, we're looking at activity 4.4 where we're using a scenario to write an equation. All right, so baby elephant nurses for the first 2 years of its life. It drinks about 10 liters of milk every day. Okay, so define my variables and write an equation to represent the relationship between the amounts of milk the baby elephant consumes and the time it spends consuming the milk. Assume the elephant maintains the same rate of consumption. Okay, so I'm going to say my x variable is going to represent the number of days. Okay, and then I'm going to have my y variable, and it's going to represent the number of liters consumed. Okay, and I'm told that it's going to consume 10 liters of milk every single day. So the amount of liters in all consumed is going to equal, so y is equal to 10x, because every day I'm going to take 10 and I'm going to multiply it by 1, or 10 times 1, then 10 times 2, then 10 times 3, and then that's going to get me the amount of liters that I would need to know. All right, identify the constant of proportionality, or my k variable, and describe what it means to me in my situation. So k is equal to 10, and this means it is 10 liters per day. Okay, 10 liters per day. All right, and then create a graph to represent this situation. So we know that my x variable, which is my x-axis right here, this is the number of days consumed. Okay, so this is x, and this is y, and the y is the amount. Can you guys see that? There you go. Amount of liters consumed. Well, I know that it's 0, 0. So let's think about this. For one day, it's 10. Okay. 2 days, it's 20. Okay. 3 days, it's 30. Where is that? Okay. So on and so on and so on. If I'm at 0 days, so before the baby elephant's even born, is it consuming any milk? The answer is no. Think about this. If I go up, so 3, then if I go to 4, it's 40. Then 5, it's 50. Then 6, it's 60. So on and so on. I'm eventually going to have a graph that's going to look like this. And my graph is proportional because it does two things. It is a straight line, and it goes through the 0, 0, the origin. All right. Let's try another, or no, let's actually finish it. Sorry. Thought there was another one. Huh. All right. The weight of an object on Earth, it varies directly with the weight of an object on the moon. So a 150-pound object would weigh approximately 25 pounds on the moon. Okay. So define my variables and write an equation. All right. So I'm going to say that my x variable, it's going to represent the weight on Earth. Okay, because I want to know the relationship between the mass on the Earth and the weight on the moon. So meaning I want to know if it weighs 150 pounds on Earth, how much is it going to weigh on the moon? So my x variable is the weight on Earth, which is what I know, and I'm finding my y, which is the weight on moon. Okay, which is my weight on the moon. All right, in order to write my equation, I need to find and identify my constant of proportionality, my k variable, which is my y variable over my x variable. Okay, well, I have my y variable. It's right here. It's 25 pounds. So I have 25 pounds over my x variable of 150. And I need to get and simplify this down. All right. Well, I know that 5 can go in there, but let's think, can 25 go in there? And 25 can. Well, 25 divided by 25, that is 1. And let's see, 25 or 150 divided by 25. Let's see, 25, 50, 75, 100, 125, 150. It can go in there 6 times. So my K is 1 over 6. Okay. And describe what it means to me in my problem. That means 6 pounds on Earth, or let me rephrase that. Let's just make it easier. That the weight on the moon is 1/6 the weight on the Earth. So weight on moon is 1/6 the weight on Earth. Okay. And we can turn this into an equation. So I know that my base equation is y is equal to k times x. Well, I now know k, so I'm going to say y is equal to 1 over 6 times x. And then it wants me to create the graph. Well, let's see. My x variable was weight on Earth. And my y variable is weight on Moon. Okay. Well, I know that if I'm at 0, I'm going to have 0 and 0. And I know that for every pound I go up for Earth, I'm going to be 1/6 of that. And as it keeps going on and on and on, it's going to end up being a straight line, meaning it's going to be constant. Okay. All right, and let's try the last one, 4.5. Multiple representations of a proportional relationship. All right, so I'm going to suppose that Q varies directly with P. Complete the table for variables P and Q. All right, meaning usually they're X and Y. They just gave us two different letters this time. Okay, so I need to create my K column here, and I'm going to sit here and see, is this going to be, we know that it's going to be proportional. So I want to know 6 divided by 2. So 6 over 2, well, that's 3. 12 over 4, well, that's 3. Okay, so I'm going to assume everything is 3. Well, if x is 0, y has to be 0. Okay, because I'm multiplying by 3 every time. So I'm going to take 0.25 and I'm going to multiply it by 3, and I'm going to get 0.75. I'm going to divide by 3 here, so I know that that's going to be 1 because 1 times 3 gets me 3. And then 1.5 times 3 gets me 4.5. Okay. Write an equation that represents the relationship between P and Q. And I'm going to say X and Y because we're used to seeing it in the form of X and Y. Well, I'm going to have Y is equal to K times X. And I know my K variable, we just found it up here, to have Y is equal to 3X. Okay. Summarize how you can write the equation that represents the relationship between two variables that vary directly if you're given a ratio. Okay, so basically if I'm given a table, how did we do this? So the first thing that we did is we found our K variable. Okay, we found our K, and then the second thing is we wrote an equation. Okay, so the first step was we define our K variable, and once we found our K variable, then we had to write an equation to represent that. All right, looking at it as a graph. Okay, so this was our X variable, and this was our Y variable, and it's going to look like this. We don't even really have to kind of like plot any dots because we know that when X is 0, Y is going to be 0, so I have to plot it at 0, 0. And then for every one I go up, or every one I go over on the x-axis, I'm going up by 3. So 2, 6, 3, 9, so on and so on. All right, so summarize how to draw a graph from equation and represent that for that two quantities. So since we know that there is a proportional relationship, so since it's proportional, we can plot a dot at 0, 0 and draw a straight line. Okay. And then number 6, summarize how you write the equation representing the relationship between two quantities varied. Let's see, sample choose to clean up here. And that's kind of what we did with our graph is so we chose another point on the table, okay? Oh, on the graph. Okay, so if we had a graph here, so what we did is we chose another point on the table to find K and write, I'm going to finish this, an equation. So this question here is saying, given a graph, I did not read that all the way. So if I was given a graph here and I had this point 2, 6, what we would have done is we would have chosen, 2, 6, we would have chosen this point here. We would have seen that, okay, it's at 6, so pretend that's going to be 6 right there. We're 6 over 2, And so we chose a point on the graph and found our K variable. Okay, we chose another point on the graph that was not 0, 0, and we found our K variable. All right, if you guys have any questions, please let us know.